Dear students, in this episode, we are going to discuss the properties of maps and cartographic signs and symbols. This episode consists of the following sub-modules: Introduction, Properties of maps, Visual variables, Classes of symbols, Legibility, Cartographic Symbolization, the Symbolization Problem, Measurement Level, Features Dimension Lists, Ordering Visual Variables. Introduction, Properties of maps. Many properties can be measured on the Earth's surface independently of its geography. Some of these properties are area, shape, direction, bearing, distance, and scale. The first part of a map you need to know is its title. The title tells you what the map is showing. A map showing settlements or land use or name of the streets of your town is its title. A compass helps you to find direction. A simple compass may look like a plus sign with arrows. At the end of the arrows, the 4 cardinal directions would be listed. They are north, south, east, and west. The top arrow would point to the top of the map, which is north. The bottom arrow points south to the bottom of the map. The next important part of the map are the symbols. Maps show a smaller picture of the Earth's surface. You can't draw a life-size mountain on a small piece of paper. That is why cartographers use small pictures. Symbols are the points, lines, and patterns that are listed in the map key. The key is a box located in one of the bottom corners of the map. Symbols have different colors depending on the physical features the drawing represents. For example, water features like rivers, lakes, and oceans are colored blue. Trees, orchards, and shrubs are usually colored green. Red is used for important roads. Buildings and mountains are colored black, while mountains and hills are colored brown. Cartographers use different symbols on maps to represent real features from the world. 3 common types of symbols are point, line, and area symbols. Cartographers use point symbols to show exactly where one thing, a school or a hospital, for example, is located on the map. The symbol is usually a dot or a picture. When a feature is long and in the shape of a line, cartographers use line symbols to represent these things on the map. A blue line is used for a river and a black line is used for a road. When something on a map is not a specific point, but rather a whole area, a cartographer uses an area symbol. These symbols shade an area to represent places such as forests, urban areas, and oceans. In order to represent data in a meaningful way, you must be able to identify and discriminate between map symbols. This process is made possible by varying the appearance of symbols. Point, line, area symbols constitute the primary building blocks of pictorial representation. We call these marks the basic graphic elements because they can be used to create all visual designs. Point symbols convey a sense of position. Line symbols exhibit direction as well as position and can be thought of as a linear array of points. Area marks exhibit extent, direction, and position and can be thought of as a two-dimensional array of points. Visual variables. We can make point, line, and area marks on the way appear more or less distinctive and prominent by altering their shape, size, orientation, or color. We call these graphic variations the primary visual variables. Shape. Shape is the graphic characteristics provided by the form of a graphic mark. A shape may be regular and geometric, as in the case of a square, circle, or triangle. Size. Marks vary in size when they have different apparent geometric dimensions: length, height, area, and volume. Orientation. Linear and elongated shapes exhibit the visual variable we call orientation. A directional frame of reference is needed to define the orientation of a graphic mark. The graticule may serve this purpose. Hue or color. Hue is a very important and complex visual phenomenon. When we say things are different colors, we are usually describing characteristics such as blue, green, red, and so on. Value. As a graphic quality, value refers to the relative lightness or darkness of a mark. A surface that reflects a noticeable amount of light is said to have a tone. Instead of tone, it is better to use term value, which refers to the perpetual scale of lightness and darkness. In the perpetual scale of values, light is referred to as high value and dark as low value. Chroma. As a graphic quality, chroma refers to the degree to which a hue departs in colorfulness from a gray tone of the same value. Chroma can range from a gray hue with no apparent color pigment to a pure hue with no apparent gray. Terms such as saturation, intensity, and lightness are also used to refer to this complex visual variable. Repetition of basic graphic elements representing various combinations of these primary visual variables produces an aerial graphic effect that we call pattern. In turn, pattern exhibits the characteristics of arrangement, texture, and orientation. These aspects of pattern are made up of component marks that are characterized by the primary visual variables. Thus, we call pattern arrangement, texture, and orientation the secondary visual variable. Arrangement. Arrangement refers to the shape and configuration of component marks that make up a pattern. The pattern of points or lines may be random or systematic in structure. Texture. Texture refers to the size and spacing of component marks that make up a pattern. A fine texture is produced by a close spacing of small marks. This contrasts with the coarse textured pattern produced by an open arrangement of larger marks. Orientation. It refers to the directional arrangement of parallel rows of marks as they are positioned with respect to some frame of reference. Classes of symbols. The primary and secondary visual variables contain the essential visual ingredients of all maps. In order to consider the way you can use symbols, it is helpful to classify them. A three-class scheme of point, line, and area symbols is popular. This would make sense if there were direct correspondence between the geometry of map symbols and the environmental phenomenon they depict. A better way to classify is to focus on their spatial emphasis. Zero in on what the symbol represents, not what it looks like. This approach yields point, line, and volume emphasizing symbols. Point emphasizing symbols. Point symbols are individual signs such as dots, triangles, and so on used to denote a position, the location of a feature, the intensity at a place. Examples include a coordinate location, a radio tower, a spot height, the centroid of some distribution, or conceptual volume at a place such as population of a city. Even though the mark may cover some map space, it is a point symbol if it refers conceptually to a location. Line emphasizing symbols. Line symbols are individual linear signs used to represent a variety of geographical phenomena. Line depicting rivers, roads, and political boundaries are common examples. But use of a line symbol does not always mean that the class of feature being represented is linear. For instance, contours are lines used to represent elevation and depth data from which volumes may be determined. Area emphasizing symbols. Area symbols are markings extending through a map area to indicate that the region has some common attributes such as water, administrative jurisdiction, or some measurable characteristics. When used this way, an area symbol is graphically uniform over the entire area it represents. The homogeneous character of the symbol may result from an even color, or it may consist of uniform repetition of point or line symbols. Volume emphasizing symbols. Volume symbols represent the vertical or intensity dimension of a spatial phenomenon through space. In landform mapping, for example, the terrain surface may be generalized with non-uniform marking that produce value or lightness variation, as is the case in relief shading. The land surface may also be represented by spot height data, point symbols, or linear surface traces such as profiles or contour lines, which are line symbols. The four classes of symbols along with alphanumeric annotations make up the basic building blocks of cartographic representations. But in order to endow the marks with meaning to make them similar or different from one another and to make them more or less prominent, you must adjust their appearances by using the visual variables. Legibility. Whenever you use graphic symbols, the first rule is to make sure that they are easy to read and understand. To do so, you need to choose the proper graphic marks and portray them clearly. The shapes of point symbols must not be confusing. Lines must be clearly distinguishable in form and width. Difference between colors, patterns, and shadings used to differentiate between symbols must be visually distinct. One important aspect of legibility is size. No matter how much care you put into producing a symbol, it serves no purpose if it is too small to be seen. Some types of symbols are inherently more visible than others. The width of line symbols may be reduced considerably since the length seems to enhance visibility. Similarly, contrasting colors or shapes may increase visibility, but these enhancements have a limited impact on legibility. Another quality that affects legibility is familiarity. It is easier to recognize something familiar than something new. This you may see as a name in a particular place on a map, and even though it is too difficult to read, you can tell what is from its position and general shape. Cartographic symbolization. A map can represent important geographic characteristics in a far more understandable, interesting, and efficient way. The process of creating graphic symbols to represent feature attributing values is part of what we call symbolization. Since tabular data exists in many forms and are available from a wide variety of sources, cartographers spend great effort deciding how to symbolize feature attributes. When cartographers symbolize attributes which are derived parameters, two different generalizations have taken place. The first is the parameterization of the attribute value, and the second is the symbolization. Features exist in a real world, and the cartographer's task is to portray these features relevant to the map being created. Cartographers turn to the symbolization process after they have applied classification, simplification, and exaggeration routines to features selected for mapping. Symbolization is the use of visual variables to represent the data summarizations resulting from classification, simplification, and exaggeration. This graphic coding makes the generalization visible. The symbolization problem. Symbolization begins with stylizing or typifying attribute values. The symbolization process includes selecting the level of measurement, nominal, ordinal, or interval, to use in the feature's visualization. It also includes choosing the dimensionality of the feature, point, line, area. All features exist in a combination of these two aspects. All these features can be mapped in a combination of these two aspects. The way the features exist and the way they are mapped need not be the same. Cartographers, therefore, must perform important symbolization tasks before they choose the symbols. They must select the measurement level of the original data values and conceptualize the dimension for each feature they wish to portray. Making these two choices is the essence of the cartographic symbolization problem. Let us look more closely at each of these tasks. Measurement level. All attribute values of features existing in reality can be measured on one of the four measurement scales defined as nominal, ordinal, interval, and ratio. When we symbolize data on a map, we can generalize down the measurement scale from ratio to interval, ordinal or nominal, from interval to ordinal or nominal, or from ordinal to nominal. But we cannot generalize up the scale. We cannot change from nominal to ratio, for example. And we must map nominal data as nominal data. We have no choice. Most symbols cannot only qualitative or quantitative data. The only way we can portray interval or ratio scales is to use textual or numerical annotations to enhance the symbols. Features dimensionless. We think of features as having dimensionality ranging from 0 to 3 dimensions. A point feature is dimensionless or 0 dimension. A line feature has 1 dimension. An area feature has 2 dimensions, and a volume feature has 3 dimensions. We use point, line, or area marks to represent data associated with point, line, area, and volume features. Ordering visual variables. When cartographers use the primary visual variable such as value, size, and chroma in symbols, they create a visual ranking. Ordering these 3 primary variables are called the ordering variable. The ordering variables are useful for point, line, or area reference feature attributes. They can be used to portray features attribute at the ordinal interval or ratio measurement of scales. Perhaps value is the most basic of these ordering variables because it is impossible to have visualization without variations in values. Size is one of the most useful variables in cartographic symbolization. Size inherently connotes differences in quantities. Color is the most subtle of these 3 ordering visual variables. It is less visually effective than lighten, value, or size. At times, it is useful to combine chroma and value and to vary these 2 visual variables simultaneously to reinforce the magnitudes being symbolized. In contrast to the above ordering visual variables, The remaining three primary visual variables like hue, orientation, and shape are differentiating variables. They can be used to differentiate amount feature attributes referring points, lines, or areas. Admittedly, hue is sometimes used in the spectral progression to represent height of land and depth of seas. When hue is used in this way, the map must be carefully designed and supplemented with numbers and text. The orientation is best used to show nominally selected differences. Orientation refers to the angle at which the symbol is placed on a map. Different angles connote qualitative differences. Shape. Shape is also useful in connoting qualitative differences in attributes. It is particularly effective when applied to line symbols. For example, shape variations. Let us define solid, dashed and dotted lines so that they are easily distinguishable on the map. Orientation is more useful for symbolizing points or areas than for line. Shape is best used for point or line symbolization and not for areas. Hue is useful for all the three. There are also three secondary variables. These variables are created by repeating the basic graphic effect that we call pattern. These secondary variables are arrangements, texture, and orientation. Texture can be used as ordering visual variables. In all cases, cartographers should use these secondary variables to enhance a symbolization, not as the only visual variable to differentiate a feature attribute value. Thank you.